Hello everyone. Our topic for the day is naive-Bayes classifier. As the name implies, it is used in this case. I have used it to explain how naive-Bayes theorem is used for classification. So, as we all know, naive-Bayes is again used for both classification and regression. If the data values is discrete, it is used for classification. The data value is continuous. It is being used for uh, uh, regression. So in order to say like if it is discrete, like yes, no, true, false, you can, the ultimate purpose is classification. If the data value is continuous, like whether the share price will increase, whether a particular employee's salary will be revised or not. On certain cases, on checking the continuity, it is used for regression. In today's topic, I have used naive Bayes in order to explain only the classification. And this in real-time examples, it is used like whether in order to identify whether an email is spam mail or not, in order to do the sentimental analysis, in order to classify articles, the type of article that is being used or published in newspaper. And talking about the name based, the reason is that the term name stands for, that is, the existence of one particular event or feature will not affect the existence or entry of one another event or feature. So that is why it is termed as naive. And the reason for Bayes is that it makes use of the Bayes theorem, which is already available, and put together it is called as naive Bayesian classifier. And now, talking about the assumptions that this naive Bayes theorem makes is that feature independence, that is, the existence of one feature, which is I was already talking about, the existence of one feature will not affect the entry or existence of one another feature. And if the values are normally distributed, the features will be continuous. And if the values are multinomially distributed, the features will be discrete. And it is said that none of the features should be exempted, and each feature is equally important. And while presenting the prior data, none of the data or none of the attribute value should be left empty. That is, there shouldn't be any missing data. And now talking about the Bayes theorem, the probability of event X to occur, when there occurs this probability of this event Y is identified with the formula that probability of Y occurring with respect to the existence of event X multiplied by probability of X divided by probability of Y. So we already know that the definition of probability A and B, that is the probability of event A to occur and the probability of event B to occur, whereas none of these probability of A and B should be zero, and probability of B is the event A to occur, and probability of A with respect to probability of event B that exist. So this is how these Naive theorem works. And now we can see the particular terminology that is used to call each probability. Whereas the probability of event A and probability of event B is called as prior probability. That is whether or not it is a spam mail, whether or not I'll play tennis. All these things are called prior probability. And posterior probability is the resultant value, right? Likelihood probability is nothing but uh, how far those things happen with respect to each attribute value. Say the temperature can be so and so, the humidity can be in such can be strong, weak, the wind can be strong, weak. So each particular value for that day is put together called as X, right? So this is called as likelihood probability. So this is how each of these probabilities are named with. Now taking an example, that is that an observation that is made for around 14 days is given like this. So with respect to these 14 days uh, presented here, I call this table format as uh, feature matrix. Feature matrix, so we all know what is matrix and feature. Feature matrix is nothing but I have certain features called outlook, temperature, humidity, wind. And what is the resultant value with respect to uh, the happening of all the attribute values? Is all these things put together or presented together is called as feature matrix. And response vector is nothing but the observation that is being made for a day. So observation that is made for the first day is one response vector, right? So observation made for one another day is another response vector. Vector is nothing but a row. Response vector is with respect to rainy day, with respect to hot temperature, with respect to high humidity, and with respect to a windy day. What was the decision made by me? Whether I'll play golf or I'll do not play golf, right? This thing is called as response vector. So now talking about the evaluation of whether or not to play golf on a certain day is nothing but probability of prior probability, that is yes or no, with respect to that observation that is being made for certain attributes like outlook, temperature, humidity. So the resultant value will be of probability of one particular attribute, that is outlook. What is the probability of yes or no? Here if it is yes, here also it is yes. And with respect to the probability of the next attribute, that is temperature, what is the probability of yes? Similarly, for all the attribute values you have to identify, and that has to be in turn multiplied by the overall probability of y. I can rewrite this formula in such a format, that is the probability of y multiplied by product of I to n with respect to x of I, right? So I can rewrite this formula as probability of y into product, that is product of probability of xi for each y, for each yes, right? So this will be my resultant value. From this resultant value, I'll take whichever is the highest value, that is the maximum value, argument max. Why argument is the solution will be in decimal places, right? So now taking one such condition, so I have identified the prior probability for the observation made for around 14 days. Totally 9 days I have played golf, and for 5 days I haven't played golf. And the attribute value and their probability of playing golf or not playing golf, right? So this is the resultant value or the conditional probability that I have observed, right? Now, I am given with one use case like today is sunny and the temperature is hot, whereas the humidity is normal and there is no wind. The wind is false. Now I have to identify whether or not to play golf for one such day with certain conditions. Now I'll identify the probability of yes on a sunny day, the probability of yes on a hot, the probability of uh, humidity being normal with respect to yes, the probability of no windy day, and yes, on a no windy day I have played golf, right? So these are the values that is multiplied by the probability of yes. These values I'll take it from the conditional probability and prior probability table which we have seen in the previous slide. So the resultant value is 0.0 to 1. Similarly, I'll identify the probability for no, right? So on a sunny day, not playing golf is 3 by 5. On a hot day, not playing golf is 2 by 5. On a normal humidity day, the not playing golf is 1 by 5. And for a no windy day, the probability of not playing golf is 2 by 5. And the overall probability of no is out of 14 days, 5 days I haven't played golf. So the resultant value is 0.007. Among these two, the one which is higher on the higher end is probability of playing golf. So on a sunny day, whereas the temperature is hot and the humidity is normal and there is no wind, on one such day, the probability of playing golf is yes, I will play golf, right? Now, in order to assess whether or not I have evaluated the previous evaluation correctly, usually the probability of yes or no will be value 1, right? So I'll do one such evaluation, the probability of yes for today divided by probability of yes plus no, whereas the resultant value is 0.75. And the probability of no for today is the probability of no divided by probability of yes plus no, whereas the resultant value is 0.25. On adding these two values, I should definitely get the value as 1. If it is 1, my evaluation in the previous steps are correct. If not, I have made some mistakes in the previous evaluation, right? So this is how I'll make a classification using a discrete value or labeled data in order to make a classification, right? So that's all about naive Bayesian classifier. Thank you so much for patiently watching my video. Please let me know in the comments how was the uh, video, and drop in the comments what video I should post next. Thank you.